Continuing on with confidence intervals, number 6 is also a confidence interval for means, so we have to go through the same steps. First, we have to associate 90% with a specific z alpha over 2, in this case 1.645. Then we have to multiply that by s over the root of n. Again, because we were given s squared, we're going to have to take the root of 0.095 instead of putting it in directly as 0.095. Then we're going to have to divide that by the root of n, in this case 171. If I put that all into my calculator, 1.645 parentheses the root of 0.095 divided by the root of 171. I get a margin of error of 0.03877. I'm going to go to 3 decimal places here, so 0.039 is what I'm going to call this. Always go by what it asks for. From this 0.039, I know that's how far I'm going to move to the right and left off my x bar. My x bar up above was 0.92. So I'm going to take that 0.92 and subtract 0.039. I'm going to take that 0.92 and add 0.039. The end result is going to be a lower bound, which is 0.881, and an upper bound, which is 0.959. Question 7 asked me to do a confidence interval, except this time it asked me to do it for a proportion. When I need to do it for a proportion, first thing I need to calculate is p hat, which is x over n. In other words, how many fit the 83 successes out of how many total were in my sample, 1600. If I put this into my calculator, 83 divided by 1600 gives me 0.051875. I'm going to call that 0.052. In general, you want to go to at least 2 significant digits here. I know it's all being graded online to the system, so if it really is just a slight rounding error, I will give you points back on the test, but for the most part, try and go to at least 2 significant digits. That should match up with what they're doing. Once I have my p hat, my margin of error for one of these problems is going to still be that z alpha over 2 value that are the same for means. Difference being that instead of multiplying by sigma over root n, I'm going to be multiplying by the root of p hat 1 minus p hat over n. So in this case, the z alpha over 2 value for 99% is 2.575. I'm going to be multiplying that by the root of 0.052, 1 minus 0.052, divided by 1600. Once I put that all in my calculator, 2.575, parentheses, the root of, parentheses, 0.052, end parentheses, new parentheses, 1 minus 0.052, end parentheses, divided by 1600. I get this to be 0.014. If I then take my p hat, 0.052, and I first subtract 0.014, then I take the 0.052 and I add 0.014, that gets me to my final confidence interval, which is 0.038 to 0.066. Questions 8 and 9 really just ask me to set up HO and HA. Whenever I have a null and alternative hypothesis that I'm trying to find, I need to remember that the null is always going to be an equal to sign, no matter what. For the alternative, I'm trying to determine, is it greater than, less than, or not equal to, based on what the researcher's trying to prove. Here it says the researchers trying to prove that defectives drop below 0.3%. If they're trying to prove that defectives drop below that, they want a less than alternative hypothesis. So the first thing we have to do is set up that it's an equal to for the null and figure out whether it's less than, greater than, or not equal to for the alternative. Next thing we have to figure out is whether we're dealing with a proportion or a mean. Whenever I see a percentage like that, that's probably going to be a proportion. In this case, the defectives dropping below 0.3% is a proportion P. So I use the letter P for my population value. If it had been a mean, I'd want to use the Greek symbol mu, which you can pull from the math type thing in Cengage. Now that I know I'm dealing with P, I need to know what to compare it to. This percentage, 0.3%, needs to be written as a decimal. This question threw a lot of people off when it was in the work for doing tests of proportions. Basically, people thought that it was okay to write P equals 0.3, P is less than 0.3. But what 0.3 really means as a decimal is 30%. When I want to change a percent to a decimal, I need to move that decimal over twice. So this really would be based on 0.003, not 0.3. For number 9, it says current germination is 98%, but a new process should change that. Find the null and alternative. Again, I'm going to start by always putting an equal to sign for the null, and then trying to determine if the alternative is less than, greater than, or not equal to. Here it said the new process should change the germination rate, but it didn't tell us if the new process is going to make it higher or lower. For that reason, the alternative hypothesis here is not equal to. In this case, the germination rate is a proportion or percent. That's why I use the population value P. If I move the decimal twice, that's how I get to 0.78. So my alternative is P is not equal to 0.78. My null is that P is equal to 0.78.